The object was already past us before anyone truly understood what it was. By the time telescopes locked onto it, the calculations were uncomfortable, not catastrophic, not headline-worthy, just wrong enough to make experienced scientists stop talking and start recalculating. It wasn't large enough to end life on Earth, but it was large enough to end cities, large enough to erase coastlines, large enough to change history. And for several hours, quiet, unannounced hours, no one on Earth knew how close it had come. This is not the story of a meteor strike. This is the story of a near miss that almost wasn't noticed at all. In the early 2000s, humanity believed it had a decent grasp on the sky. Satellites circled the planet. Space agencies tracked known asteroids. The assumption was simple. If something dangerous was coming, we would see it. That assumption was wrong, because space is vast, telescopes are limited, and most threats don't arrive from where we're looking. This object didn't approach from the darkness ahead of Earth. It came from the direction of the sun, blinded by light. For ground-based telescopes, this was the worst possible angle. The glare made detection nearly impossible. The sky looked empty, safe, normal. Meanwhile, a rock the size of a large building was crossing Earth's orbital path at tens of thousands of miles per hour. No alarms sounded. No emergency meetings were called. No governments were informed. Life continued normally below. By the time the object was finally detected, it had already passed closer to Earth than the Moon, closer than many weather satellites, closer than some communication systems, close enough that, had its trajectory shifted by a fraction of a percent, the impact point would have been inside the atmosphere. That realization came later. At first, it was just a blip in data, something unusual, but not immediately frightening. Astronomers logged it, ran simulations, cross-checked orbital paths. Then someone noticed the margin. The margin wasn't measured in millions of miles. It was measured in tens of thousands. In cosmic terms, that's a breath. In human terms, that's survival by accident. If the object had entered Earth's atmosphere, it would not have burned up harmlessly. At that size and velocity, it would have detonated with the force of multiple nuclear weapons. The shockwave alone could have flattened a major metropolitan area. Windows shattered hundreds of miles away. Power grids collapsed. Communication systems severed. And if it had struck water and ocean impact, the resulting tsunamis would have reached coastlines hours later. Not instantly, not dramatically, but inevitably. Entire regions would have had time to realize what was coming, and nowhere to go. What makes this event unsettling isn't just how close it came, it's how quiet it was. There were no sirens, no public warnings, no emergency broadcasts, because no one knew the discovery happened after the danger had already passed. The calculations were completed in hindsight. The relief came with a delayed chill. This wasn't prevention. This was luck. Pure, unrepeatable luck. This near miss didn't make front-page news. There were no documentaries at the time. No Hollywood adaptations. It was filed away in scientific journals, buried under technical language and orbital diagrams. But within space agencies, something shifted. Because this wasn't a hypothetical scenario anymore. This was a rehearsal without an audience. And it revealed something deeply uncomfortable. Humanity was not watching the right parts of the sky. Most asteroid detection systems were designed to look outward into the darkness of deep space. But this object had hidden in sunlight, invisible until it was already gone. A blind spot. One that couldn't be fixed quickly. one that still exists in many ways today. The question no one wanted to ask out loud was simple. If this one slipped through, how many others already had? And more importantly, how many wouldn't miss? The object was given a designation, numbers, letters, a sterile label that stripped it of its threat. But some of the scientists who ran those late calculations didn't forget the feeling. The moment when the math finished loading, the moment when the simulation stabilized, the moment when they realized they were alive because of chance, not preparation. This wasn't the closest call humanity would ever experience. It wasn't the largest object. It wasn't the fastest, but it was the moment that proved something terrifyingly clear. Earth does not get warnings. It gets luck. And luck doesn't repeat itself forever. After the calculations were archived, something else followed. Silence. No press conferences. No emergency funding announcements. No public acknowledgement that Earth had just failed a test it didn't know it was taking. Officially, nothing had happened. But quietly, inside observatories and space agencies, the language began to change. Because once you accept that a building-sized object can pass Earth unnoticed, you are forced to confront a far worse idea. Detection is not protection. It's just observation, and observation can come too late. Within months, astronomers began reviewing historical data, old telescope images, archived sky surveys, nights when the stars were recorded but never closely examined. They weren't looking for impacts. They were looking for ghosts, objects that had already passed by mist, not because they were invisible, but because no one had been looking in the right way. What they found was unsettling. There were near-Earth objects that had come closer than the moon without being detected until days later. Some were small, harmless, others were not. Each discovery rewrote the timeline of safety humanity believed it had. One case stood out. A previously unknown asteroid had passed within a distance that, in cosmic terms, was almost contact. Its trajectory had intersected Earth's orbit so precisely that a slight gravitational nudge from Jupiter, from Venus, from nothing more than solar radiation could have changed everything. It missed not because the system worked. It missed because the universe didn't roll that number. The uncomfortable truth was this: Earth exists inside a shooting gallery. Millions of objects cross near-Earth space. Most are small. Many burn up harmlessly. But the dangerous ones don't announce themselves. They don't glow. They don't roar. They arrive quietly, at orbital speeds that leave no time for second chances. And until recently, we were mostly blind to half the sky. Governments began funding new detection programs, but progress was slow. Space telescopes are expensive. Launch windows are limited. Politics moves slower than asteroids. Meanwhile, the near misses continued. In one instance, an asteroid passed between Earth and the Moon inside the orbit of satellites used for communication and navigation. If it had broken apart, debris could have triggered a cascade of satellite failures. Not extinction, but chaos. Air traffic disrupted, military systems blinded, financial networks destabilized, all without a single impact on the ground. This is where the story stops being about rocks in space and starts being about fragility. Modern civilization doesn't need a crater to collapse. It needs interruption. Satellites don't just provide convenience. They provide timing, positioning, synchronization. Remove them suddenly, and systems built over decades lose their reference points. Near misses don't have to hit Earth to hurt it. They just have to pass close enough. There was another moment, one that never made headlines at all. A mid-sized asteroid passed Earth at a distance, so close that amateur astronomers detected it after the fact, not professionals. By the time observatories confirmed its path, it was already outbound, vanishing back into darkness. The realization spread quietly through scientific circles. We were not in control of the situation. We were reacting to it late. For the public, space remained distant. Governments coordinating global responses. Heroes saving the planet with seconds to spare. Reality offered no such drama. Real danger arrives unannounced. Real survival looks like ignorance, followed by relief. And relief doesn't build defenses. The worst part wasn't the near misses themselves. It was the pattern. Objects approaching from the sun's direction. Objects detected after passing. Objects large enough to matter. Each one proved the same thing in a different way. Earth's survival depended less on technology than on probability. Scientists began using a phrase they never wanted to say publicly. Statistically inevitable. Not extinction tomorrow. Not disaster next year. But eventually, given enough time, an object will arrive on the wrong trajectory at the wrong moment and we will not see it coming. And somewhere in the background of all these calculations was a quieter fear. What if the next object isn't a near miss? What if it's already on its way, hidden in light, silent and unseen? The problem wasn't ignorance anymore, it was time. Even if an object is detected, early warning doesn't mean early safety. An asteroid discovered weeks before impact leaves almost no options. Months are better, years are ideal. But years require luck, because detection depends on where the object comes from. Manned space does not approach politely. One of the most disturbing realizations came from simulation models. When scientists ran thousands of impact scenarios, they found something counterintuitive. The most dangerous objects were not the largest ones. The planet killers get attention, they get funding, they get movies. But medium-sized objects, the ones capable of wiping out regions, not species, were far more common and far harder to track. A rock, a few hundred meters wide, wouldn't end civilization. But it could erase a country's infrastructure in seconds. It could trigger economic shockwaves that ripple worldwide. It could destabilize a planet already stretched thin, and those objects are everywhere. Then came a moment that shook confidence quietly but deeply. An asteroid passed so close to Earth that its trajectory was measurably altered by our planet-esque gravity. Not enough to hit us, but enough to change its future path. That meant something terrifying. Earth itself could unknowingly redirect a harmless object into a future collision course. A near miss today could become a direct hit decades later. The universe doesn't forget momentum. This realization reframed everything. Near misses weren't just lucky escapes. They were unfinished stories. Each one left behind a modified orbit, a new equation, a future uncertainty waiting silently in space. To the public, space threats still felt distant. But inside scientific circles, urgency grew. New missions were proposed. Space-based infrared telescopes designed to look toward the sun to watch the blind spots. Planetary defense offices were established, not because disaster was imminent, but because pretending safety was irresponsible. The language was careful, calm, measured, but beneath it was a shared understanding. We were not prepared. There was no planetary shield, no guaranteed deflection system. No emergency plan that could work on short notice. At best, there were ideas. At worst, there was hope. And hope is not a strategy. What makes near-space disasters uniquely unsettling is not destruction, but invisibility. They don't leave ruins. They don't leave memorials. They leave nothing behind except data and questions. Most people will never know how many times Earth has narrowly avoided catastrophe. How many times survival came down to a decimal point in an orbital equation. History books don't record what didn't happen. That's why these moments vanish. But the sky doesn't reset. Objects continue to move. Orbits continue to shift. The clock never stops. And somewhere, far beyond our atmosphere, there are rocks already on paths we haven't calculated yet. Some will miss, some won't. The difference won't be morality or meaning. It will be timing. The most honest conclusion scientists have reached is also the most uncomfortable. Earth will be hit again, not as punishment, not as destiny, but as physics. The only question is whether humanity will see it coming next time or learn about it only after the silence. By the time the data is archived, the danger always feels smaller. Numbers replace fear. Charts replace silence. Probability replaces memory. Near misses become footnotes. That's how humanity survives them. In the years following those quiet encounters, nothing dramatic changed on the surface. Cities grew. Technology advanced. The sky remained blue and predictable. Night after night, stars appeared exactly where they were expected to be. The absence of disaster became proof in the public mind that there was never a threat at all. But space does not operate on reassurance. It operates on motion. Somewhere far beyond Earth's atmosphere, objects discovered decades ago continue their paths. Their orbits are recalculated occasionally, refined with better data, adjusted for gravitational nudges that no one felt at the time. Most will never matter. A few already do. And one day, one of them will matter all at once. This is the part of the story that never makes people comfortable. Because planetary defense is not like other threats. There is no enemy to negotiate with. No warning system that guarantees time. No response that works every time. Detection does not equal control. Even today, the majority of near-Earth space remains untracked in real time. Objects smaller than a few hundred meters can still approach undetected, especially from the direction of the sun. And those are exactly the objects that can cause irreversible damage without ending the planet. The kind of damage history remembers. The unsettling truth is simple. Earth is not protected, it is observed. An observation is reactive by nature. Somewhere in a control room, an astronomer will notice a faint anomaly in a data stream. A movement that doesn't match expectations. A trajectory that deserves a second look. At first, it will feel routine. Then the calculations will narrow. And for a brief moment, before any announcement, before any warning, the future will hang on math. That moment has happened before. More than once. You are here because the answer was miss. Near-space disasters don't announce themselves with fire. They pass quietly, leaving behind nothing but relief and unanswered questions. They are erased by the very fact that they didn't happen. But erased does not mean resolved. Every near-miss is a reminder that Earth exists inside a system that does not care about progress, borders, or readiness. It moves according to gravity, and chance has never been loyal. The sky will look the same tomorrow. That's what makes it dangerous. Because the most destructive events in history don't always arrive with warning. Sometimes they pass close enough to remind a sand, then disappear, taking the lesson with them, until the next one doesn't miss. This wasn't a story about destruction. It was a story about how close it already came, and how quietly it could come again.